Hello, this is Jeff here, and we are back with Minecraft and Immersive Engineering. We're not using any of Turing Complete today. Still working on our quest to build a working redstone computer using the Immersive Engineering mod instead of just vanilla Minecraft. To give an idea of what people can do with the Immersive Engineering mod and exploring all the different logic circuits and everything in Immersive Engineering that most people don't use. So, last couple of episodes, or maybe this is previous episode, which is probably last month at the rate that I upload with this, because this takes a long time, I'd shown a system using the Immersive Engineering redstone wire connectors in conjunction with sticky pistons and treated wood planks and some shenanigans to make a switch, more like the traditional one that we have here currently. And it's still being kind of dumb. I know why. There we go. So yeah, it is always fun to weed out the ghost signals. That is why this takes so long. Because here, this is just a wonderful example of a ghost signal. I didn't think this would have an output down to there, but it does. So suddenly, it's not shutting off. But if I do that, and now it works correctly. Yes, the ongoing fun of ghost signals. So the problem I ran into with the original idea I had of using these redstone wire connectors and putting them there and there is that, as I discovered, if we cut the connection, that was all fine and dandy. But if there was a signal going through, and these were active with an output, well, the sticky piston wouldn't actually disengage. So we're going back to the old system, as that was the only way it would work correctly. Which isn't a big deal. It works perfectly fine for the intensive purposes of what we need it to do. So that's that part. Now we come back into the other test area where we're testing out the logic for part of the Substation selector. And that's just these things in here, logic circuits in the logic unit as always. And it's just fairly simple. We have the ore, light gray and cyan. And then we have the purple or cyan. As long as one of those is gone, or on, signal goes through, and then it goes to white for the output. So now, if there's any signal other than nothing, because Substation 0 is no signal to be selected, if there is any signal, it shuts off, it deselects the substation from anything. And that is highlighted by this. And my builder has apparently died. Okay. So now we've got all the logic set up for this to work. And it works nicely. So I'm going to grab this, I'm going to run over the substation, and I'm going to put it where it needs to go. Alrighty, so we're back to the substation, and this is the chaotic mess that is the grand selector switch, basically, and the connection bus to the substation. I could make this look more of a mess, but this is what it looks like. I had to go back to the traditional ones because that's how it ended up being. Which is really unfortunate, but such is life. Oh well. So, we're going to toss these into here in the correct order, and now we can commence testing. Currently, it's backwards. I'm going to have to fix that later. Right now, if there is no signal, it's disconnected, and I can fix that just by doing that for the time being. And then we're going to just connect you to there, and now we commence the testing. So, one signal in the light gray, everything is off, as it should be. No signal coming in, everything is connected. Then we bring you in, everything is off, as it should be. And there we go. And then we turn that on, it is all disconnected again as intended. So we start turning all these things on in different patterns to represent selecting different substations. It stays off, as it should be. But if there's nothing, there we go. It's all connected. Now the only thing I have to do is set it up so the local override works, which actually will be very easy. Yeah, it should be quite easy. Okay, and now, boom, it works. So, ta-da! There we go. The disconnect switch for the substation is completed. It only took me a month. Really, the reality is, if I had more time and actually sat down and did it, it would have taken me less than a week. But there's actually like a 2-week time frame where I played literally no video games or anything and was doing other stuff, because that was life. So I didn't actually have any time to work on this for whatever reason. But now it is all working completely as needed. Now the next stage, I have to set up the override, the local override, so that it doesn't deselect quite so many things, come to think of it. Because I still want I want all of these signals to still go back to the base. I just want to have all this, well, not so much this. I just want to have these disconnected. So that'll just be a little bit of extra rewiring, which I'm not going to do on camera. I'll show it to you when I'm done with it. So, don't forget to like, share, and subscribe, and we'll see you next time. Alrighty, this is Gen Jeff here. So, yeah, well, I said I wasn't going to rewire everything on camera. I ended up modifying the circuit boards to do what I needed to do. So, now, if I hit the local override, it disconnects all the control signals. Blue, whatever color that is, brown, green, red, and black are all now disconnected. Although maybe I shouldn't disconnect the master switch. Yeah, I think I'll just set you back to white. There we go. So now the controls are overridden. So if the local override is on, then you can't control the substation from my base. You can only control it locally. But if the local override is off, everything is properly connected again. And you can see what I did. So, light gray and cyan goes to register 1. Purple or cyan goes to register 0. I put cyan in there twice. So register 1 and register 0 are used. I want to change the order so it's 1, 0, 1. Register 2 is orange. Register 3 is register 0 and 1. And white is register 1 or 0. And then magenta is register 2 or 3. And it all works together perfectly to create the local override switch. So I can override the controls from the main base. I think I'm missing something here. Let's see, blue, that brownish red color. Why do I have that? Yep, it's there. 1, 2, 3, 4. Yeah, so all I'm doing is overriding 4 signals. And that way it can only be controlled from the substation control space, which is up here and partially set up. So we have the line selector. Now I have to make the control board over there with the override switches and the ability to actually control the substation. Which means I have to route the main wire from my base down 2 floors into here and run a wire from that area down to here, and then everything will be done for this part. And this is actually somewhat a slightly programmable machine because it does have memory and can save it and be programmed based off of that. It's not a lot of memory. It is a whopping 3 bits of memory with this right here, but it is memory. And this is an isolation board in the same style as these big isolation boards up here. So yeah, they're outs, those are ins, stops crosstalk, and everything is pretty much wired up and ready to go. Cool, we're getting there. We're getting there. So, see ya next time. Don't forget to like, share, and subscribe. Hello, I hope you've enjoyed the video. Don't forget to like, share, and subscribe, and hit the bell icon and all that wonderful fun stuff, because subscribing to YouTube is no longer enough. Hit all the things. Hit the like button. Like the comments. Comment multiple times. And don't forget to share. But subscribe and hit the bell. See you next time. Bye. I think our tank exploded. Whee! There it goes!
The plane or our tank?
Well, there's a tank flying through the sky.